Hey, students, welcome. This is our lesson from Thursday, January 29th. Take a look. These were the four sections that you got to walk through to choose your own adventure. Literal equations, what is the solution, both a two-variable equation and a system of equations. Then we're going to talk about solving by substitution, and then word problems. So we're going to start at the slide 13 and work our way through. I encourage you to pause, try out the problems by yourself, and then come back. We're going to need at least 2 videos to walk through this, so stick with me. The first literal equation here is ax plus b equals c, and we're going to try to solve that for this variable x right here. Remember, think about all the operations you can undo to get there. So let me pull this into a new slide and we'll walk through it. Again, the answers are for you on slide 17 if you want to just take a look at those. But as you look at this, we have ax plus b equals c. And so I'm going to highlight the variable x. And I like to talk about what's happening to x, right? What's happening to x? And we have a little list here. The first thing I can see right next to it, it's being multiplied by a, so times a, and then it's being added to b. So to undo those two things, you can work your way backwards, right? First subtract b from both sides, and then we're going to divide by a to both sides. So let's do those steps over here. Ready? Let's see where that went. Ax plus b equals c. First step, we're going to subtract b from both sides because I need to get the variable by itself, so c minus b. Then I'm going to divide both sides by a. A divided by a is 1, so I have x, and then c minus b over a. I can't combine any like terms because those are all different, and so there is your first literal equation. The second literal equation looks a lot like what we see when we're solving for systems of equations, right? And so let's take a look at this one. Again, pause it, try it out on your own. We're trying to solve for y this time, and so it's always about, okay, what's affecting y? So we have y, it's being multiplied by 3, and it's being added to 3x. So to undo those, we're going to first subtract both sides by 3x, then divide by 3. So let's go to the right side here. 3y plus 3x equals 12. I want to get y by itself, so that's where we're going. Subtract both sides by 3x. Right? And so we end up with these eliminating, and we get 3y equals 12 minus 3x. Divide both sides by 3. Y is equal to 12 divided by 3 minus 3x divided by 3. I like splitting it up sometimes. Helps my thinking. It's kind of like distributing the division. 12 divided by 3 is 4. 3x divided by 3 is 1x, or we just write it as x. So you could write it in this way, which it shows up here, or you could write it in slope-intercept form, y equals negative x plus 4. Both are correct, but this is the only one listed. All right. Try the next one on your own. Let's see here. We'll just keep going. All right, and then think about the things that you need to do to solve for h. All right, and then practice. We'll be back. All right, did you pause it? If you didn't pause it, try it all on your own. Get ready for that assessment on Monday. And here we go. First, list those things that are happening to h, right? What's happening to h? It's being multiplied by 2, right? That's the first thing. It's being added to 6p, and it's being divided by 4. I do those in order. I kind of think I start close, the next thing, and then the next thing. All right, you can do these in any order, but you can't do them in any order. They start to get out of whack here if you do them the wrong way. So we're going to multiply by 4 first, then I'm going to subtract by 6p, and then I'm going to divide by 2. All right, so 6p plus 2h all over 4 equals 5. I'm going to multiply both sides by 4. I show that by doing that there, and that there. I like to use the brackets. It keeps it separate, keeps me knowing what I'm doing. So if I multiply something by 4 and divide by 4, they eliminate. That's why we do it. And I'm left with 6p plus 2h equals 20. All right, then we said the next thing we were going to do is subtract 6p from both sides. And I'm left with 2h equals 20 minus 6p. Then 2 times h, so I'm going to undo that by dividing. I have to divide everything on the right side. I get h equals 20 divided by 2 minus 6p divided by 2. H equals 10 minus 3p. And that's how you solve a literal equation for a variable. Keep practicing, keep reviewing. You've got this. So this seemed to be one of the most difficult questions or sections for students, and I just want to talk about what it means to be a solution to an equation. Right? If we have one variable, the solution is that answer. But if we have two variables like our linear equations, the solutions are an ordered pair for each of these values and anything in between, right? It could be the decimals. All these parts of a line are made up of points and such a wide variety. So let's just walk through these. When we say what is a solution to this, I want you to know there's an infinite number of solutions. It's any xy that makes this true. Any xy that makes it true. So if I test it, say I just plug a 0 in for x, right? Let's make x equal to 0. I would get 2 times 0, that's 0, plus 4, that's 4. That would be my y variable, my y value. So the ordered pair 0, 4 is a solution. How many solutions are there? Infinite amount, right? So take a look here. Here are just a list of some of the possible solutions. And you see as x goes up by 1, y is going up by 2. Do you know why that is? Well, our starting point is 4, right? Remember our tiles? X is 0, y is 4. And then it's going up by 2 because our change, right, our slope is 2 times x. So any input we put in for x, we multiply by 2, add 4. And so this is just a few of the infinite number of solutions. And if you look at this one, same idea. 3x plus 2y equals 12. Okay, so I'm going to just walk through two of the easiest solutions to this are called the intercepts. If you haven't dug into that, right, to find what is the y-intercept, let's let x equal 0. So I get 3x plus 2y equals 12. I'm just deciding to do this, right? I get to pick a value for x, put it in here, and I get 3 times 0 plus 2y equals 12. Well, 3 times 0 is 0, so I just have 2y equals 12. Divide both sides by 2, and I get y is 6. So when x is 0, y equals 6. So I'd have the solution 0, 6. And then the other really easy one to do is, when you have this written in standard form, is make y equal to 0. And so if I have my equation 3x plus 2y equals 12, let's make y 0. 2 times 0 is 0. Plus 3x equals 12. I get 3x equals 12. Divide by 3. Boom. X is 4. So when y is 0, we have x equal to 4. And so that order pair would be 4, 0. And that's two of these possible solutions. If we look at this graph here that we put in this solution here, you can see this point right here is 0, 6. And this point right here is 4, 0. All of these other points that show up on here are solutions to this linear equation. A two-variable equation, all of these possible points are solutions, right? And so you can go up and down and see all of those awesome solutions that show up. Like this one right here, 2, 3, right? I think 2, 3. So questions, make sure you ask those, and then join us in office hours Friday. All right, so when we have a system of linear equations, then we have three possibilities. It can either be one solution, no solutions when we have parallel lines, or infinite solutions when the lines are identical. And if you see y equals negative x plus 4, if you multiply everything by 2, you get 2y equals negative 2x plus 8. They're exact same line. And so we have infinite solutions because anything you plug into one will work in the other. All right. Most often, right now, we're going to see one solution, right, where our two lines intersect. That point where they intersect is called the solution, and it is an ordered pair. All right. So if you look at each of these, what is the solution? Find that ordered pair right there. Okay, and you can click on here, and you see the ordered pair. The x value is 6. The y value is negative 4. If you tested that in here, you would get 1/2 of 6 is 3. 3 minus 4 is negative 4. Right? If we plugged in 6 here, we get negative 6 plus 2. That also is negative 4. See, that value works for both of these equations. It is the solution to both of them. All right? And then one more time, you can try these out on your own. All right? And then go ahead and check your answers right here on slide 28. All right? So if you're trying to determine if this is the solution, you take 3, plug it in for x, take 7, plug it in for y. You get, does 7 equal 6 plus 1? Yes, that works. Plug in 3 here. Negative 3 times 4 is negative 12, plus 7, that's negative 5. But if I plug this y in here, it's 7. Does 7 equal negative 5? No, right? And so this one is not a solution. And that's how you can tell it's not a solution. It needs to work in both of the systems in order to be a solution. All right, so hopefully that helps you with your what is a solution to a linear system. We're going to come back here in just a moment and look at how to use substitution in these problems. So check out the second video, but first work through slides 30, 32, and 34 on your own. You can check the answers, but we'll walk through those in video number 2.